Hey guys, we're going to be going over making API calls in Python and making API calls asynchronously so that we can actually make more API calls. So we're going to be going over how to make API calls from the AlphaVantage API. This is a financial data API that you might use to get a lot of data very quickly using requests. And then we're going to get it asynchronously using aiohttp and Asyncio, and then we're going to do a second version of that. So let's actually look into getting the data from the AlphaVantage. And if we click on one of these examples from the AlphaVantage API, we can see here's kind of a sample response that we would get. So let's look into how we can make these API calls to get the data into our code base here. And remember, all the code that we're going to be working with is going to be in the description. So let's go ahead and import requests. Obviously, you'll have to pip install it if you don't have it. We're going to import OS because we're going to be using some environment variables. And we're also going to import time. And that's going to be to actually time the functions to see, so we can see what the difference between our requests and our async is. We're actually going to time it. So now, in order to make calls to the API, to the AlphaVantage API, we do need an API key. You can see here at the end, API key equals demo. So API key equals, my API key is set as an environment variable. So I'm just going to do os.getEnv AlphaVantage API key. If this is confusing you, you're like, wait, what? You can go ahead and just replace this whole thing and just do, your key here, whatever your key is. But mine set it as an environment variable. Then we're going to do URL equals, and we can go ahead and grab the URL. This endpoint gets like company overview, which you might use to build some type of quant model. And we're going to abstract out the symbol and the API key, just so that we can add those manually in a little bit. And then we're going to come up with a list of symbols that we actually want to pull from, right? So maybe we want Apple, Google, TSLA, TSLA, MSFT, PEP. And we're going to save all the results to a list here, results. Now, the easiest way to do this is just to loop through the symbols. So for each symbol in symbols, response is going to equal requests.get URL.format symbol API key. So this is going to make this API call, but with whatever symbol here, and then with our API key, right? And it's going to resemble, making this call right here, and this should be the response that we get. And then we'll do results.append response.json. And right, we can even do like a print got symbol Python AV request by. Got Apple, got Google, got Tesla, got Microsoft, got PEP. Great, now let's go ahead and actually add some time to this too. So right before we start calling the APIs, we're going to do a quick print, saying timer started, start equals time.time. And then at the end, we do end equals time.time. Total time, it's going to be end minus start. And then we can print it took total time seconds. Okay. And then we can let's even get rid of this Python, and then we'll do timer started, and it took that many seconds, and then we'll even do to make len of symbols API calls. So let's try it again. It took 1.5 seconds to make 5 API calls. Great, so this is how we do this in requests. And this should look pretty familiar to most of you. And this is generally what a lot of people start with when making API calls. And I'll even zoom out a little bit just so we can see all the code here. So this is good. It's taking 1.5 seconds to make 5 API calls. And if we use more APIs, it's going to take even longer. Keep in mind that the free API key from AlphaVantage is rate limited, so you might not be able to test more than 5 here. But like, let's do a whole bunch here, and we'll start the time, and we'll see how long this random large amount takes. All right, so this one took 11 seconds to make 50 API calls. So as you can see, this isn't really scalable. Let's say I had like an index where I needed 2,000 prices at different companies, or I needed 2,000 company fundamentals. I can't really make thousands of API calls in a short amount of time. So I need a better way to do this. Luckily enough, there is a better way. When we do this request.get function, we actually make a request out to the AlphaVantage API, and while we're waiting for a response, we just wait. Right? We're not doing anything once we make this request. We're just kind of sitting here and waiting. And then when we get the response, then we go, okay, great. We got the response. Great. Results.append response.json. And then we do that for the next one. So we make a request, and then we wait, and we wait, and then we get a response, and then we go ahead and append that. Now, we're wasting a lot of time because we're doing a lot of waiting here. Doing a ton of waiting. It would be great if we could just go ahead and for all 5 of them, kick them off, wait, and then get all 5 responses back periodically, right? Instead of having to send one, wait, get the response, send one, wait, get the response. It would be great if just, hey, here's all the requests, let's get all the response back. That would be much faster. So, and this is where asynchronous programming comes into play. So let's actually learn how to do this asynchronously. So we'll create a new one called async run.py. And we'll do this asynchronously. And we'll even, we'll get rid of this comment first. We'll even just start by copy pasting this whole thing into here, right? So we're going to even start in the context of requests. Now, Python just reads from top to bottom and does one line after another. So it'll set the API key, it'll set the URL, it'll set the list of symbols, set the results, it'll print timer, it'll print start, it'll do request.get, wait for a response, and move on, which is great. But to work with async, you actually need a way to kick something off and then check to see if it's done later. You need something running in the background to see if the API call has returned. This is the event loop. The event loop is a loop that's checking to see, hey, this thing that we did before, is it done? If yes, your processor will stop and go do that thing for a little bit. Sort of like saying, ping me when this is done. But we need to tell Python, hey, this is going to be asynchronous, and could you please ping me when this is done? And it's going to constantly check to see if whatever input-output operation that you've done is complete, right? An example of an input-output operation is going to be API calls, maybe database writes, file opens, etc. So let's see what this actually can look like. Now I am just going to wrap this into a function here. Get symbols, because it's going to make us working with async a little bit easier. We're going to run get symbols, and if we run this code, it's going to do exactly the same thing. Took this many seconds to make 5 API calls. Okay, great. Now, requests is a synchronous library by nature. What does that mean? Well, it means that every time we do request.get, we're actually going to be, making the request, then waiting, and then responding. And this is that nature that we kind of want to get rid of, right? Because we're spending a lot of time waiting, and we don't send the next call until this one's already done. So let's just learn about working with Asyncio. So let's first import Asyncio, because we're going to have to use Asyncio anytime we do any type of async operations. And we're also going to need to import aiohttp. And this is the async version of requests. Now the rest of this is going to stay the same, but this part is actually going to be drastically different. So the first thing we want to do is we're going to take this function and we're going to tell Python that it's an async function. Async functions still can work exactly the same as regular functions, and we can even just run this with requests back in, and it'll be normal here, right? Well, pretty much normal. You can actually already see it's a little bit faster. Hopefully, after I explain what's going on, you'll understand why. But when we call a function async, we're telling Python this async keyword turns this into an asynchronous coroutine, and it means that we can await it. And then this async keyword turns this into a coroutine, and it means that we can await this and do asynchronous stuff with it. Don't worry about that for now. But let's get rid of requests again. Now we have this async function, but we need a way for Python to know, hey, you're going to be doing some stuff and we're going to be checking back. Now we have this async function, but we need an event loop running to check to see when some of our asynchronous requests have actually responded, right? Because remember, right now we're doing request, we're sending a request, waiting on response, and then we're getting the response for each one of these. Instead, we want to send a whole bunch of requests, and we need something listening for the responses so that each one can come and find. We need something listening for all these responses and can do stuff with it when it returns. So this is called the event loop. So we actually need to create this event loop. So we're going to do loop equals asyncio.get event loop. And we're going to say we want our get symbols function to run with this event loop. We're going to say loop.run until complete get symbols. And then we also need to close the loop. Now we can even import requests here and run this. So we just ran this function using an asynchronous loop. Of course, we didn't do this because we still were just sending one after another, and requests is synchronous. So we were still doing the wait respond, but we now have the syntax to actually do asynchronous work with this function. Now, the reason I started with this is because you'll actually see a lot of the syntax, but async has actually gone and abstracted this and made this a lot easier. So this whole getting the event loop and running until complete can also be just wrapped up as asyncio.run get symbols. And we can run this, and you'll see it'll be the exact same thing. Okay, great. Well, now let's try to make it go even faster. So the main issue right now is that we're running requests, and this request function, just by nature of how requests work, it always will wait for a response. We don't want it to wait for a response. We want the event loop to pick up the response instead of us waiting for the response here. So let's actually go ahead and get rid of this request bit, and let's turn this to be asynchronous. So the first thing that we're going to need to do is we're going to have to make a client session. So we can do session equals aiohttp dot client session. Requests actually has something similar, dot session, and then you can actually just do session.get. But oftentimes we don't use that because we abstract it out. But for working with async, we do want to use this client session. And whenever we're done, we want to do session.close. But it's usually best practice to actually just have it automatically close instead of us having to remember it, because I always forget and a lot of people always forget. So it's often best practice to, instead of doing it like this, we do async with aiohttp dot client session as session and tab this up. This way, when this block of code is done, this will automatically close. We're saying we need to asynchronously open a session here. Oops, and there's parentheses here. Now that we have a session open, we can go ahead and actually make the same API call that we would make with requests. The only difference is I've often found that it has an issue with SSL, so I just always set SSL to false when making my API calls. Now, if we run this, and we're just going to comment this line out for now. Now, if we run this, we're actually going to get an error. It's going to say enable trace malloc to get the object allocation traceback, and it's a little bit cryptic here. It's going to say enable trace malloc to get the object allocation traceback. It's going to say something how about client.session request was never awaited. This is a little bit confusing. And the reason is when we call session.get URL, it actually doesn't kick off the request like what we normally see in requests. This actually returns a coroutine. It returns this session.get URL function. So we actually need to await or say, hey, I'm going to wait for you to complete. When working with async functions, each line just gets kicked off, right? And we never wait for it to be complete. However, here, we actually need to have some type of a wait function to say, hey, we do need to wait for this to complete. If we run this now, you can see it returned successfully. However, this await keyword, once again, means that we're doing this request, awaiting, and then we get the response. So this still isn't even that much better. And you can see when we run this, it's really not any faster at all. So this is asynchronous syntax, but we're actually not getting the performance increase that we want because we're still awaiting for each one of these sessions to respond. When we use this await keyword, this says, hey, take that coroutine, take this async function, and wait for it to complete before moving on to the next line of code. So we do need something better than this, but this is asynchronous syntax. Really simple asynchronous syntax. So let's make a new file. We'll call it async run v2.py. And we'll just copy paste everything that we've got from async. So do Python, async run v2.py, and it should take about 5 seconds to make these API calls. Or excuse me, about 1.5 seconds to make these API calls. So how can we make this faster? Well, we want a way to kick off all these API calls at once. So we don't have to wait for each one after we make an API call. So how do we actually do that? It would be great if we could just get a list of all these API calls and just send them all at once without having to await for them to respond. Well, there is a way. We can gather up a list of these tasks that we want with a function called def get tasks. And we have to pass in this client session as a parameter. So let's start off with an empty list of tasks, and we'll say for each symbol in symbols, tasks.append session.get, and just this bit here. Return tasks. So this function is putting all of these coroutines onto a list called tasks. And we'll even print this. We'll just call this get tasks function here with session. And it should print out all of our tasks here. And you can see it's a list here of AIO HTTP client request context manager objects, also known as coroutines. So we have a list of these functions that we can call. Well, now that we have a list, we don't actually have to go through the symbols again. We can say tasks equals get that list, and we can just kick all of them off at the same time. with responses equals await Syncio.gather star tasks. So this line is saying we're going to wait for all of these to finish, right? Because we still do need that waiting period. So we send request, make a request, make a request, make a request. We do still have to wait, but we want to wait after they've all been already sent. So we're going to say we're going to await the entire list and wait for all of them to respond. This star task syntax is known as dereferencing. So it's the same as doing this, just having like this long list of these coroutines being sent as parameters. So it's actually just taking that list of tasks and actually just turning it into singular input parameters to this asyncio.gather tasks. Now, this should be much faster. Let's try this out. And we can see it took drastically lower amounts of time to do this. Let's even try it with 50 API calls. And again, if you're using a free key, you might not be able to test this out here. Or 60. Even 60 took about the same amount of time because we just kicked off all 60 at once and we got all 60 responses back at the same time. Now, there's one other thing to talk about here. When we create this list of tasks, we're just adding these functions, adding this session.getURL to this list here. And we only actually kick it off when we do this await asyncio.gather. This asyncio.gather goes through this list and kicks off all the requests, or kicks off all the session.gets, and it adds them onto the event loop that was kicked off by this asyncio.run. It would be even faster is if we could, the instant that we created them, we automatically added each task to the event loop. And we actually can do that by doing asyncio.create task like this. Now, if we run this, it's going to be pretty much the same. For our small use case, it's not really going to be any faster, and it's going to look pretty much syntactically the same, but this is best practice to just automatically add it onto that event loop with asyncio.create task. And that's actually why they're called tasks here, is because they're on the event loop. So that's something to keep in mind, is that when we're creating tasks, this automatically adds this function onto the create loop. So when we do asyncio.create task, this create task automatically kicks us off and adds it to the event loop. Without create task, we're just saying, hey, this function is going to be one of our tasks. And this asyncio.gather function, if the task isn't already on the event loop, it's going to add it and wait for it to respond. And if that task is on the event loop, it's just going to wait for it to come back. There's a link in the description to a GitHub repository with all this code. Let me know if this was helpful for you. Like and subscribe. I'm doing a tattoo reveal at 10,000 subs. So hope to see you guys soon.